Welcome to the DIY Honda Garage channel. This presentation covers the Diagnostic Trouble Code DTC P0842, which indicates a short in the transmission fluid pressure switch A, second clutch, or that the transmission fluid pressure switch A is stuck in the on position. This issue primarily affects the operation of the automatic transmission, specifically the second clutch system. The transmission fluid pressure switch is a critical component that monitors the hydraulic pressure within the transmission system. A malfunction in this switch can lead to poor vehicle performance and potential damage to the transmission system. Understanding the function and location of this component is essential for effective troubleshooting to avoid further mechanical complications. In this guide, we'll explore the definition of the error, its causes, symptoms, and detailed troubleshooting steps to rectify the problem. The error described by DTC P0842 is a fault with the transmission fluid pressure switch A, specifically related to the second clutch circuit. This switch is designed to report the hydraulic pressure within the automatic transmission system to the Engine Control Module, ECM, for proper operation. Its location is typically near the transmission assembly, where it can directly monitor the pressure of the fluid, essential for the clutch's engagement and disengagement. If the switch fails or experiences electrical shorting, it may cause the system to remain stuck in the on position, impacting gear shifting behavior. Notably, it's important to recognize that this error is not a result of mechanical transmission failures, but strictly relates to electrical circuit issues. Addressing this code early on is paramount to prevent extended transmission issues. Several potential causes may lead to the activation of DTC P0842. The most common reason is an electrical circuit problem, indicating a failure in wiring or connections that affects the performance of the pressure switch. Another possible cause is a faulty pressure switch itself, where the internal components may fail and cause the switch to get stuck in the on position. Additionally, there could be a short circuit to body ground somewhere within the wiring harness, which could lead to improper readings from the switch. It's vital to determine these causes through thorough troubleshooting to isolate the issue accurately. This understanding aids in preventing unnecessary component replacements that do not address the root of the problem. Drivers may experience various symptoms as a result of DTC P0842 being triggered. One of the most noticeable symptoms is erratic shifting behavior, where the automatic transmission may change gears unexpectedly or fail to shift at all under certain conditions. This irregular behavior can lead to generally poor driving experiences. Another symptom may include transmission slipping, where the vehicle fails to accelerate normally, causing a loss of power in driving. Additionally, warning lights on the dashboard might illuminate, alerting the driver to a system malfunction. Identifying these symptoms early and associating them with DTC P0842 assists in a timely diagnosis and repair, enhancing the overall driving safety and vehicle performance. The first step in troubleshooting DTC P0842 involves turning the ignition switch to the on/to position. This action powers the vehicle's electrical systems without engaging the engine. Once in this position, it is crucial to record all freeze data and any onboard snapshot using the Honda Diagnostic System, HDS. This data serves as a reference to understand the state of the vehicle at the moment the code was triggered. Additionally, a review of general troubleshooting information is essential to ensure that standard diagnostic protocols are followed. This preliminary step sets a solid foundation for a systematic approach to diagnosing the cause of the DTC accurately, preventing oversight of critical information that could mislead the technician. Next, clear the DTC using the HDS. Clearing the code will allow you to see if the issue persists after being reset or if it was an intermittent error. After clearing, check the second pressure switch in the automatic transmission AT data list while ensuring that the vehicle is not in second gear. It is critical to determine whether the second pressure switch is off at this stage, as this information helps to assess its functionality. If the switch shows off, it indicates that there may be no direct internal fault with the switch at this moment, prompting you to proceed to the next diagnostic step. Alternatively, if the switch shows as on, it could suggest a problem that needs immediate attention, warranting further investigation. After confirming the status of the two pressure switch, determine if the switch is indeed off. If it is off, this leads you to the next diagnostic steps for proper troubleshooting. If the switch is on, this could indicate a persistent fault that needs deeper inspection, and you would then move on to more detailed diagnostics per the outlined procedures. It is vital to assess this correctly, as it may dictate whether there's a need to replace the pressure switch or investigate issues related to wiring and connections in the system. Specifically, confirming switch status is a critical juncture in troubleshooting, directly affecting the subsequent actions and methods employed. This step tests the integrity of the pressure switch before taking any corrective actions. Start the engine and allow it to warm up to the normal operating temperature, which you will know is achieved when the radiator fan activates. This step ensures that the vehicle is under typical operating conditions, crucial for accurate diagnostics. The temperature can affect the pressure inside the transmission, hence, it is imperative to have the engine warm, which enables a better test of the transmission fluid pressure switch under real-world conditions. Ensuring the radiator fan operates also confirms that the cooling system is functioning correctly, preventing overheating hazards during the testing. During this stage, monitor the vehicle's behavior and be prepared to conduct a test drive to gauge the transmission response, which leads to the next step in your diagnostic process. Drive the vehicle in third gear with the shift lever in the Drive D position for a minimum of 2 seconds. This simulates real driving conditions and tests the functionality of the transmission under load. After the test drive, monitor the onboard diagnostics OBD status for code P0842 in the DTCs menu using the HDS. At this juncture, it is essential to assess whether the HDS indicates the status as failed or passed. If the HDS results show passed, it indicates that the system is momentarily functioning correctly, but may suggest an intermittent issue worth investigating. Conversely, if failed, this points toward a definitive problem, necessitating a move to the next troubleshooting step for deeper examination. Upon monitoring the HDS, you must ascertain whether it indicates a failed status. If it does, this result directs you to further investigate the potential causes leading to failure. Alternatively, if HDS displays passed, but you suspect an intermittent issue, you should check for a potential intermittent short to body ground in the wiring that connects the transmission fluid pressure switch A, second clutch, to the powertrain control module PCM. This process involves careful inspection of the wire harness and connections, as wiring faults can lead to erratic switch behavior or false readings. The focus should also be placed on ensuring that all electrical connections are clean and secure, thereby eliminating common sources of intermittent faults. At this stage, you need to turn the ignition switch to the lock 0 position to ensure the electrical systems are powered down, which allows for safe disconnection and testing of components. Disconnect the connector from the transmission fluid pressure switch A, second clutch, as this step allows for independent testing of the switch. Carefully handle the connector to avoid damage, as maintaining the integrity of the connections is essential for accurate diagnostics. With the connector off, this prepares you for the next phase where you will check the status of the switch using the HDS. This action is part of isolating the pressure switch from the system, allowing for clear analysis of its performance without outside influences. Next, turn the ignition switch back to the on position to re-engage the vehicle's electrical systems. This action powers the diagnostic system and allows for testing of the second pressure switch. With the HDS, check the status of the second pressure switch in the automatic transmission AT data list to determine whether it is off. In this test, the pressure switch should ideally remain in an off state. If the switch status reads off, it indicates that the component is functioning correctly while not in operation. An off reading suggests that the problem likely lies elsewhere in the wiring or PCM. Conversely, if the switch shows on, it signifies that a fault persists within the component that must be addressed to resolve the DTC. After checking the second pressure switch, if it remains off, this directs you to replace the transmission fluid pressure switch A, second clutch, due to a confirmed malfunction. Replacing this component is critical as it is directly linked to the DTC P0842 problem and will likely resolve the error code issue. After performing the replacement, it is necessary to clear the DTC and recheck the system functionality to ensure the problem has been addressed. Ensuring this switch operates correctly is crucial to effective transmission performance and vehicle operability. In cases where the switch status reads on again, further investigation is required to trace potential wiring issues or other factors affecting the switch behavior. Ensure to switch the ignition to the lock 0 position once again to disengage systems before conducting additional tests. Subsequently, use the HDS to jump the SCS line, which will initiate a specific diagnostic mode. The SCS, or Service Check System, is often used for troubleshooting to block certain trouble codes and allow for clear diagnostic monitoring. This step is vital as it prepares the system for deeper testing consecutive to the replacement of components, ensuring that potential faults can be isolated effectively. Properly executing this process will allow for an undisturbed assessment of how the system is responding post-repair adjustments, informing further necessary actions. Disconnect the PCM connector B, which typically consists of 44 pins. This action isolates the PCM, or powertrain control module, from the system. Focus on checking for continuity between PCM connector terminal B8 and body ground using an appropriate multimeter. The wire associated with terminal B8 is usually coded as OP2SW, blue-yellow. Ensuring continuity without breaks or shorts is essential for appropriate functioning of various transmission systems. A confirmed continuity will indicate that the wiring is intact, while any absence will necessitate further diagnostic measures to find shorts or breaks in the circuit that could lead to issues with the pressure switch reporting. This testing phase is crucial to ascertain whether the wiring linked to the PCM is primarily responsible for the DTC. Continue by assessing whether there is continuity between terminal B8 of the PCM connector and body ground. If continuity is present, it indicates the existence of a short to body ground between the wiring connected to the PCM terminal and the transmission fluid pressure switch A, second clutch. This short circuit can cause signals to be incorrectly reported to the PCM, ultimately resulting in the DTC error. Addressing this issue includes repairing the wiring that exhibits faults, ensuring that it is insulated properly to eliminate any grounding opportunities that disrupt the circuit. After making repairs, it is necessary to recheck the system to confirm that the problem has been resolved and that the DTC no longer appears. After completing repairs or component replacements, it is crucial to clear any diagnostic trouble codes, DTCs, from the vehicle system using the HDS. Once cleared, run the diagnostic tests again to verify that the repairs have resolved the issue. During this verification, monitor the system for any recurrence of the DTC P0842. Ensuring that the code does not reappear indicates successful troubleshooting and repairs have been conducted. Additionally, it is advisable to perform a road test to observe the vehicle under operating conditions and ensure that transmission functionality operates as intended. This final verification step is indispensable for ensuring the vehicle is in optimal working condition before returning it to the owner. To prevent a recurrence of DTC P0842, implementing preventive maintenance practices is essential. Regularly inspect the wiring associated with the transmission system to catch any wear, fraying, or signs of short circuits before they lead to failures. It's also imperative to routinely check and maintain proper transmission fluid levels. Low fluid levels can result in increased wear and tear on transmission components, including pressure switches, leading to premature failures. Keeping the vehicle up to date on scheduled maintenance will not only ensure that issues are caught early, but also prolong the lifespan of the transmission. Staying proactive in maintenance can save time and costs related to unexpected repairs and improve vehicle reliability. In conclusion, DTC P0842 specifically highlights issues related to the transmission fluid pressure switch A, second clutch, circuit, or its status being stuck on. Effective troubleshooting requires a focus on both electrical diagnostics and an understanding of the component's role within the transmission system. Each step in the diagnostic process, from initial checks to final verification steps, plays a pivotal role in identifying and resolving issues accurately. Regular maintenance practices will significantly aid in preventing similar issues from arising, securing optimal vehicle performance. By adhering to the troubleshooting guidelines provided, technicians can efficiently service Honda Civics from 2006 to 2011, ensuring seamless functionality of the automatic transmission for a better driving experience. Please like and subscribe to the channel. See you next time.